Okay, hi. Good afternoon, everyone. As you can see, my name is Matt. I'm a structural integrity engineer, and I work for a company called TWI, which is also the Welding Institute. What I'm going to talk about today is welding engineering and how far you could actually go and what options we have regarding apprenticeships, A-levels, engineering, etc. Okay, so the content, we'll talk about what welding actually is, look at my role and what I do day to day as a structural integrity engineer, and also the career paths and the options that you might have if you're interested in studying these areas. So, does anyone know what welding is? Has anyone got any ideas? Yeah? Anyone want to volunteer and answer? I'm going to grab the mic and go that way.
Okay.
You stick two metals together, or something like
That could be, yeah. So that's one type. So we stick metal together, okay. Any other ideas? Anyone else want to volunteer or anything?
Anyone at all?
Nothing? Okay, no, that's fine, I can answer that one. So, quite simply, it's a way of making high-strength joints between two or more parts. So you've mentioned metal, obviously, so that's quite an obvious one, quite a common one that we'll see. But we can also use it for many different types of material, okay, and we'll look at them in a minute. So welding, this is the most common types that you'll often see. So this is our welding and metal together. So there's two types there, manual metal arc welding on the left, and on the right we have what we call TIG welding, tungsten inert gas. So these are methods that you'll commonly see, and this is using current to be able to put the heat into the material so we can actually test and we can actually do our welds. Here's another option as well. So these are the kind of ones that you'll probably see, especially if you walk around the competition today. That's what's actually happening. That's the kind of welding that you'll see. These have obviously been, welding's been around for a long time, but these have all developed with technology, and advances in technology means that we can do them more efficiently, cheaper and cleaner. We also have some technological advances and some more advanced methods of welding. So this here is laser welding. So that's a good new one, fairly new. We also have on the left hand side there is friction stir welding. So this is basically we're just using a rotating part to put some heat through friction into the material so we can weld it together. And on the right this is electron beam welding. So we create a focused beam of electrons and that can allow us to weld. So what materials can we weld? Any ideas? I think we've heard one of them. So we've also heard metal already. Okay, so the metal, that's the most common one that you'll see. We can also weld plastic together. We can weld wood. We can weld fabric. And we can also weld ceramics. And what we can do in that case, if you see on the ceramics one, we also can weld dissimilar materials together. So we've got the ceramic on the right, and on the left hand side we've got metal. So whereabouts can we find welds? Anyone want to answer that one? Anyone know? Where can we find some welds in the real world? Any ideas? No? Okay. So we can find them in the buildings, so obviously see something like the NEC. Everywhere, welds all over the joint. Okay. We've got bridges, plant and process equipment. So here we've got a chemical plant, these chemical storage tanks. All the vehicles, various vehicles will have welds involved, whether they're by air, sea or land. Medical applications, so there's things such as pacemaker on the bottom right. We also have plastic welding on blood filters, prosthetics and things like that. Mobile phones, I'm sure everyone has a mobile phone, so we have welds in there. There's hundreds of welds in a mobile phone, which not everyone knows that. We also have welds on a crisp packet, is actually welded. Okay, and that's a metal foil or plastic can be welded for a crisp packet. Ooh. I'll go this way. That's better. Structural integrity. Okay, so structural integrity is the area I work in. Okay, that's the reliability and safe design of all engineered structures. So when we say engineered structures, that basically includes nearly everything. Okay, because we always need to take into account, if we make anything, we need to take into account at least it can hold its own weight. Okay, and then we have live loads and operating loads. So something like one of these benches obviously needs to be able to take a certain amount of weight if someone sits on it. Okay. We also have things like environmental loads, so say an oil and gas platform. We need to have a look at wave loading, wind loading, and all that type of thing, okay? And we need to keep that and make sure it can take them. We also need to look at things like impact loading. So in cars, they're built so that if there is impact, you'll take a certain amount of the force out of it, okay? So some of the areas that I look at and what type of work that you could do if you worked in structural integrity. One is fitness for service. So we've got a crane. Obviously, it's been designed to perform an intended function, so obviously to lift things, okay? But what we need to do, it needs to be able to lift what it says it can lift, so it'll be set for a certain weight, so it needs to be able to lift that weight without having any problems, so we can determine whether it is fit for its service. Also, failure investigation, so you see a part which has failed, so here we need to find out why it has failed, and then we need to work out what we can do to stop that happening in the future. We also have life extension, so there might be the case something like an oil and gas platform. It's built for a certain life. Everything that's engineered is built for a certain life, okay? So this might be around for 25, 30 years. You might get to the end of that and they might think, well, actually we can't afford to replace it. We need to keep using it, okay? So then we'd look at, can we actually use it further? We'd do certain tests. Also mechanical testing to work out material properties. So I might need to know under something like tension, so if it's being pulled, how strong it is there. We also need to know how tough it is, so if it had things like cracks, etc. in there, we need to know how tough it is and how resilient it is to any problems of that sort. And also we do computer modelling, so if a part's particularly complicated or we don't want to destroy it, what we'll do, we'll make a computer model, and then with that model itself, then we can change various parameters very easily rather than doing lots and lots of different mechanical tests. Okay, so some of the ideas, that was kind of the areas that I look at and the areas that I work in. A couple of ideas of projects and a couple of a bit of information about projects that I've worked on or been involved in. Okay, so here we have a trampoline. So you'll see this pretty standard format, this trampoline structure is what you might see in people's gardens and things like that. Okay, this is obviously built to take a certain size of person. Okay, and the manufacturer in this case was having problems that it wasn't, the joints in there weren't lasting long enough or as long as they thought they would last, so they needed to work out what was going on. So what we did, we looked at one specific joint which had welds in, so this is this joint here, and what we need to do, we need to know what type of forces are acting on there. Okay, so what we can do, we can use instrumentation and we can join that on there, so we use strain gauges and we're able to work out what type of forces go through it when someone bounces on there. So this is our testing phase. So we have someone bouncing on there wearing a weight vest. Okay, so we wanted to have them at 100 kilograms, so they're wearing a weight vest. And we have the instrumentation on the joint of interest, so we can work out what forces are acting while they're bouncing on there. Okay. Then we can use that information and we can do what we call a fatigue test. So this is where we use the forces we've got and we can put them forces through and perform a fatigue test. So we can, instead of someone bouncing hundreds of thousands of times, we can do that very quickly in a short period of time using a machine. And then from there we can see what the problems are and when it actually fails. So this one, you can see the crack there, that failed, and we can work out how many cycles, so we know how long in theory that joint would last with somebody of 100 kilograms bouncing on it. Okay. Slightly larger project to talk about is something, this is the Boston Manor Viaduct. Okay. This is basically a viaduct part of the M4 motorway which leads into London from the west side. This is one of the main routes in, okay, especially from Heathrow Airport. So in the run up to the Olympics last year, okay, this is obviously going to be a very major route for the athletes and officials, etc., coming in from the west. Okay, so what we needed to do, there was various inspection work carried out and some problems found, and they had to put a weight limit on there before the Olympics. That was obviously going to cause a lot of problem because of the heavy traffic from all the officials and athletes travelling in. Okay, so there's several companies involved, around 200 personnel involved in looking at how we could remove that weight limit. Okay, can't really go into much detail because there's still some ongoing work, but basically the project was successful and we were able to take the weight limit off that bridge and it was able to operate normally during the Olympics. So obviously that would have caused a major problem if we couldn't find a solution. What can happen if it goes wrong? Okay, well, if we don't do this correctly in structural integrity, we can have problems such as this. This is a pressure vessel which would hold chemical fluid. Okay, under a test before the flue was put in, we do a test using water, and the vessel itself fractured and failed. One of the parts that are missing, the large parts here, okay, weighed about 2 ton and was thrown about 50 meters across a car park. Okay, so that's the kind of things that can go wrong. Fortunately, in this case, there was only one minor casualty, but you can see that that could cause us a major problem. Yeah. Another example is something like what happens if it goes wrong. Okay, so this is a accommodation platform in the North Sea. So there's an oil and gas drilling platform to the side of it. Yeah, and what happened here was that basically there was a problem and it failed. There was a weld at the bottom which failed, which meant that the whole structure was overloaded and then it tipped over. Okay, and this kind of puts the fact how important something like structural integrity work is, because 123 people were killed in this event. So that shows the importance of the work that we do and why we need to try and get it right, and get it right first time. Okay, so some of the options on career paths. So we start off with GCSEs, so obviously the maths and science are particularly relevant, but there's also options such as BTECs and engineering and things like that are also particularly relevant. Then we can move on. We can either choose to do A-levels. Again, similar subjects, so maths and physics are particularly important. The other option is to look at the possibility of apprenticeships. Okay, so this is where we take a job and we'd learn on the job, and we'd also do training. So you probably have 2 days out at college getting various qualifications while also working for your other 3 days a week. Some of the options, you could be a welding technician, so actually be physically welding. You can be involved in mechanical testing, so various things there, and also metallography, so looking at materials and the way that they behave. Okay, so that's obviously quite a good option because you're able to earn while you're learning as well. Okay, and then apprenticeships can also be taken at a slightly higher level, moving straight in from A-levels instead of straight from GCSEs. Other option is then to push through into university from A-levels, studying things, various engineering, mechanical engineering, structural engineering, civil engineering, and also things like material science is also quite important. Okay, and then from there that can move into what we term a graduate job. So this could be things like a welding engineer, looking at welding processes and how to improve them. Things like myself as a structural engineer, looking at structural integrity, and also a metallurgist looking at new materials and new processes there. If you do go down an apprenticeship level, that doesn't mean you're stuck in that area. You can also move through, gaining your qualifications, and you can push. If you want to continue, you can move across and keep going into these sort of more research and consultancy areas. Okay, so that's all from me. That's a very quick rundown at the end of the careers pass. Basically, if you, we have the welding area down at the other end of Hall 3 where the welding competition is happening. There's also people around there to talk about various welding careers. They're all at different stages, so you can visit there. We also have a couple of links to our websites, and we also have an email that people can contact. There's a few brochures here about welding engineering and kind of the options in there. And thank you very much. Do we have any questions?
Any questions at all?
No? Excellent. Thank you very much. Thanks for listening.
A round of
Thank you.
applause for Matt then.